Okay, welcome back to the second part, second installation of the mechanic problems that we have in dynamics, physics 11. So we've reviewed how to draw a diagram of a free body with all the forces included on it. So you have your body, you have Fg, you have the normal force. This is a terrible drawing. I've changed my settings, so excuse me. This is friction, it's moving, and FA. Interestingly, we can call this F1, FA, F1, F2, F3. And now we are going to do problems that include many masses. Many masses will have many drawings to find out what the final vector is. Often those two are the same, and then those two compete with each other. Fk slows down F1, but F1 ends up winning if we push hard enough and accelerates. So let's take a look at the Atwood machine. Atwood machines, a laboratory device consisting of two masses and connected by a string stretched over a pulley. The machine was originally designed by George Atwood in 1784 to study Newton's law of motion with constant acceleration. So basically this thing is more massive. Mass 2 is more massive than mass 1. If you set them and then you let them go, what do you expect to happen? You expect mass 2. Let me try and draw this. So if you have ole. I have to relearn how to draw a little bit. Okay. This is M1. Oh my goodness. M1. There's a pulley. And it doesn't matter their position, but we could use the difference in their position to talk about acceleration, because this is the distance, and by a certain time, we can find the acceleration. So that's useful. But if M2 is greater than M1, you can expect this thing to go down. And so if M2 is greater than M1, it goes down. If M1 is greater than M2, then this mass would go up and M1 would go down. Okay. Interesting, Charles. Problem involving Atwood machines often involve finding the acceleration in the system and the tension in the string, right? When solving problems, assume that I have assumed it. The string and pulley have no weight. Thank you. So the string doesn't have weight, the pulley doesn't have weight. We're only thinking of them as like light strings with forces moving the masses. The string and pulley have no friction, so not slowing down the movement because there is no friction. We assume it because it's easier to calculate. And then when you feel comfortable, you can add the fact that there is friction in the wheel. The string does not stretch, right? So a string normally stretches a little bit. And then it changes the position of the masses if it stretches. And we can assume that if mass 2 would be lower, there would be more stretch. And if M1 string is smaller, there would be smaller stretch. You can all calculate that. We will not do that right now. the tension is constant throughout the string. Yeah, more complexity that we do not include. For each problem below, write an answer with all your workings. You don't really need to do all this, no? They will prepare you for the next level up. But you should try them. You should do them. So you should pause me and do it. I will be doing it to guide you. Two masses are attached to a lightweight cord that passes over a massless, frictionless pulley, as shown in the image. The mass of M1 is 3, M2 is 4. Check, draw an FBD. Practice. An FBD for each mass. We have M1, again, pause me right here and do it. M2. So M1, if we look at it, it has its own weight, which I call FG1, and a tension T1. M2 has FG2 and T2. Okay. Yes, so the same things. What is the acceleration on the smaller mass? Okay. And we have the masses. Let's write down the masses. 3 kilograms, 4 kilograms. I'll try to go fast, but there will be some things I want to review. So the acceleration on the smaller mass. So M1 is what we want the acceleration on. So we want to know what the acceleration is. I expect those two to have the same acceleration. One down, one up. So the quantity will be the same. And this is going to be part of which formula? It will be part of the sum of Fy or Fnet. And Fnet will be P1 plus Fp1, and it will give us a mass acceleration. In this case, P1 is not what we're looking for. We're looking for the acceleration, which will be P1 plus Fg1 divided by the mass. Right, so all I did was saying, okay, I want to isolate this because this is the question. And so I've made my formula. I have T1. I don't have T1, but I have Fg1. And can we assume that the tension 1? So here's what I think about this problem. This problem, if you have a mass like this, or if you have a pulley where your mass is like this, and this other mass is on the table, or if you have two tables, you have your masses here, pull, you can have them pull on each other. I think that T1 is going to be the same as T2. T1 is up, T2 is up. Right, so T1, the tension in the cord, if you cut this cord off, there's no more tension. This tension is caused by T2, T2's friction, or whatever it is that's moving this here. In other words, is it safe to assume that T1 is equal to T2? That this T1 is equal to this T2? I assume so. Again, we'll look into that in details. But if it is the case, if that's the case, then it allows us to do different things here. We can find what T2 would be. T2 here would be what? So let's do some. Oh, the lessons. Sometimes the lessons, they go like that. And I don't care. Sum of Fy T2 plus Fg2, which is equal to Ma2 or M2A. This is M1. And so basically T2 would be okay. T2 would be M2A minus Fg2, right? Simple. If this is the case, then I don't want a formula where I both have A's. As you can see here in this formula, how I can isolate A. I can say that A is T2 plus Fg2 divided by M. And if this A is the same as this A, then we could say A equals A because it's the same. And then we could say T1 plus Fg1 over M1. Is equal to T2 plus Fg2 over M2. I believe that's true. The problem here is that we lose the A that we need. And we normally use this kind of work when we don't have something and we don't have other thing like this. So if this is the case, then I can write T2 is equal to T1. And if T2 is equal to T1, then I've transformed two unknowns into one unknown, and now I can solve it. But instead of saying A is A, we will say T2 is equal to T1. And if the tension in both of these problems is the same, this is linked, if these are the same tensions, then we can write formulas for T1 and T2 like such. This one here. And this we can erase. We're going to write a formula for T1 is equal to MA minus FT1 we're going to need this. We're going to need this. Here, MA minus F1 equal to, and that's MA1 is equal to M2, same acceleration, because they're linked. They accelerate at the same rate, minus Fg2. So what does that allow us to do? So we have M's, we have M and G, and we have M2. We have everything except the A's. And we can find what they are in this expression, because that's the only letter that we don't have. Oh, wow, I find this overly complicated, but also right. Mg, this is M1G, is equal to M2A minus M2E. So M1A minus G, remember this, and M2A minus G. No, I don't want to put A in a bracket, right? We don't want to do that. What do we want to do again? Isolate A. We're trying to isolate the A. So we would write M1A minus M2A. Send that over here and send this to there. M1G minus M2G. And then we end up with A, M1 minus M2, which we can calculate, is equal to G, M1 minus M2. Simple math. All I did here was clean it up a bit so that I can enter the information. Boy, there's an issue. If we cancel this on both sides, we get that A is equal to G, which is not true. So we have a problem. What did they write? Oh, give me a break. The mass of M1 is 3, and the mass of M2 is 4. Now let's just understand what the heck is going on. So G is minus, right? In his formula, G is positive. Right? That's the only thing. How do I get this? Minus M1G. I get this minus M1G if this is a positive, not a negative. And we would do that if this would be a positive, not a negative. How do we fix this problem? And what does it mean? But if inside the definition of T, which is M2A, by the way, this A is different, isn't it? Right. This A, hold on. The A1 and A2, hold on. These two masses accelerate in the same, they have the same vector. They don't have the same vector, that's the point. They have the same scalar, but the direction is opposite. So in other words, A1 is equal to minus A2, right? It's the opposite direction. If you say this accelerate up by 5, then this accelerate down by 5. Okay. Well, that's the issue, isn't it? Because now we can write M1A1 minus M1G equals minus, yeah, minus M2A1. So A2 is transformed into minus A1. Oops, minus M2G. I bet my whole day's value that this is the issue. This is the simple issue. M1A1 plus M2A1 is equal to M1G minus 2G and A equal to G M1 minus M2 over M1 plus M2. Okay. We got it, chat. It was literally this important idea that screwed up my math. So my math is good, and this is so important. Right. And now it gives us the right equation. Okay. Okay. I just did not respect something, and that's what it did to me. Right. Nice. Draw this again. When I have a beautiful formula I can use with the same situation every time. So let's review the formulas. Maybe this is when I'm going to restart the video because it took me a while. So let's do it again with number 2. Block A has mass of 1.2. Let me try to get your attention here. M1 is 1.2 kilograms. Okay, we're going to redo it. This time I will draw the Atwood. We have 2 masses. M1 is equal to 1.2 kilograms. M2 equal to 3.2 kilograms. We have a vector here, F2, a tension, T, which we will just call T because it's the same on both sides, and an F1. So T is influenced, right? So imagine you have a string. You pull on the string, I pull on the string. There's a tension in the string. If I pull harder, you have to pull harder. Right? It's not a choice that you have if I pull harder, that you don't have to pull harder. So this T is going to be the same tension. This T is created here not by people, but by 2 force. If this force increases, right? If this force increases, the T increases. If this force increases, the T increases. See this? This has to be reflected. Almost see this. This idea has to be reflected in the mathematics that we choose. Okay. So let's talk about the mathematics. So how do we do this? So this still, there's two masses. It still reacts like two different problems. We're gonna do Fnet on both of them. Fnet here will be T plus Fg, which will be equal to M1 A1. This is why I cut the movie, because I made a mistake or I didn't note that and it screwed up everything. But the truth is, the acceleration for both of these masses, right? The acceleration for both of these masses are going to be the same. If this one goes up by 5 meters per second, this one's going down by 5 meters per second. Or if this mass pulls down 2 meters per second, the other mass has no choice but to go up 2 meters per second, because there's no stretch in the string. But this is going to be important. Let's do the other side. Fnet is equal to what? So T plus Fg2. And that's equal to MA or M2 A2. And in this case, it's not the same acceleration. And can we say what we mean by that? Can we say why that would be the case? Because I can put 1 and 2s everywhere. Like I can put a T1 and a T2. And I can put FG1 and FG2. But for some of them, they are the same. Right? So if I write like this, we can say that T1 is equal to T2. First off, right off the bat, they're equal because they're equal. They're the same. They're just T, or just call it T. And also A1 is equal to A2 with a little precision, right? Because if this accelerates up, then this accelerates down. And because it's the same magnitude, we'll leave it as a direct relationship. So if this is 4, then this is 4. But the minus here will ensure that if this is going up by +4, this is going down by -4. So that was my mistake earlier and why I had to cut the video, because I didn't find it. I couldn't find it. Then I found it. Okay, so by saying this and by saying this, we will come back to those ideas in a minute. So first off, we'll just write P. The tension is equal to, so for the first half, tension is equal to M1 A1 minus FG1. Now remember, this Fg is the negative G. And for the other part, we're also saying that T2 or T is equal to M2A2 minus F2. Okay, so first off, where am I going with this? I'm going to make the Atwood formula that we're going to use. So I'm just trying to give you an idea of how to make that formula in physics. So is this true up to now? Anything confusing? This is true, right? We've done this before. This is true. We're just summarizing the two diagrams that we are seeing here. Okay, and then we're just replacing T2 and T1 for just T, because it's the same tension. And then we're focusing on T, And the reason why we're doing this is so that we can unite them into, if t is equal to t, because they're the same, right? Or we can just say, what is equal to m2a minus fg2? What is equal to this? It's this, and this is also here, and it is represented by this. So we can write m1a1 minus fg1, because it's the same t, right? We need not to forget that. It's the same t. If it's the same t, it's the same value, it's the same everything. And so how we get there, we can get there from this equation or from this equation, and we just put them both here. Right? From there, we're really doing good. We are going to be also changing our A's. So M1A1 minus FG1 is equal to M2 times minus A1 minus FG2. So basically, this is the idea that the acceleration up for one of them is the acceleration down for the other one. So instead of using A1 and A2, we're just going to use A1. So that means that the acceleration that we're going to find will have to do with this first mass. Okay? So if we find a positive 3, it means this is going positive 3. And it means this is going negative 3. Simply because of this. And now we're ready to do the Atwood formula. M1A1 minus M1G equals, and I'll put the minus in front, M2A1 minus M2. From here, we are going to put all the A's together and all the G's together. M1A1 plus M2A1 is equal to M1G plus M2G. Okay, so here all I did was do a plus M2A on both sides, plus M2A on both sides. So this canceled out this part and moved it on the other side. Right? And for this, I did plus M1G on both sides, plus M1G both sides, canceled that, and added this. Oops. Plus M1G. Made a small mistake with the plus here. A minus, right? And then we can isolate our A1 in M1 plus M2. And we can isolate G in M1 minus M2. And we can divide both here. Let me try to do this here. We're going to divide by M1 plus M2. This is what's really happening. It's just happening so fast in my head that I just do it. But if you divide by, I'm going to need a break. You divide by m1 plus m2 on both sides, and you get g m1 minus m2 divided by m1 plus m2. And this is the Atwood formula that we can use. Now that we have this, we can answer the problem here. Would we have done it another way? Yes, right? Because we simply substituted these things for t. So by finding t, we could find a. But as you can see, can't find the acceleration if you haven't found t. And in this problem, they ask you to find t after. So they ask you to find a first and then t. And is there any other way to do it without doing this formula or t? I don't think so. I don't. So we're going to use this formula for a, 2a. What is the acceleration? So acceleration will be g. I can put that here. I don't know if it matters much to write them down, but they have to be written down somewhere. So g is minus 9.81. Don't need to write that down necessarily. You're on Earth. The mass 1 is 1.2 kilogram. Mass 2, 3.2 kilogram. Acceleration g times m1 minus m2 over m1 plus m2. So minus 9.81 times 1.2 minus 3.2, and then 1.2 plus 3.2. A simple formula. So the first part is minus 9.81. So I'm just doing this first here to show you a few things. So this is 2 minus 2, and this is 4.4, which can actually be written as 1 and 2.2, right? We're just simplifying. The minus goes away, the 1 times this is this. So all you're left with is 9.81 divided by 2.2. The acceleration is 4.46 meter per second square. And B, they asked for the tension is what? So we already have our units, we don't write them again. The tension was either one or the two that we had prior, right? So M1A1 minus FG1 was one of the formulas that we had to have T in this problem. So we will just replace 1.2 times 4.46 minus 1.2 times minus 9.81. And the tension, so this 1.2 mass, so this times 1.2, 5.35, 5.351 plus, because minus minus, 1.2 times 9.8, 1, 1177.2. and the tension, we'll be adding those together. I'll do that here. 5, 3, 5, 1. Right. 5 minus 0.51 plus, what is it? 0.351 equal 17. I may have made a mistake, but I think this is the right answer. This is the tension. We'll take a look at both answers. 445, 446, and 17 Newton. So we're finding shortcuts. You know, this is definitely a shortcut for the Atwood. Great formula. Let's give it some respect. Right. This is the Atwood 2 mass. Yeah, you get it. Atwood 2 mass. Okay, let's continue. Lab. Not sure about the labs. Don't think we're gonna do any of that. See the distance here? Yep. Construct the Atwood, record the masses, raise the mass, measure the distance, measure the time, get these information, percentage error. Okay, so we're not doing this, right? Just to show that the equation works. Please don't do the lab. Next. Hanging blocks from a table problem. So there's without friction and then with friction. So again, we'll continue and do them. We'd probably check the videos, but I don't want to enter into a copyright issue. As with the Atwood machine, for these problems, it assumes that same thing. Okay. Is it gonna tell me another formula again? Well, our previous method worked if we had seen the problem that arose prior to. Okay, so let's draw it. 2 mass, 1 Atwood. How hard can it be? Oops. M1 equals 5.6 kilos. M2 3.4 kilogram. I just noticed that I'm still in the note-taking view. My bad. Yeah, what's up? Let's look at the problem together. So this is the problem that we're looking at. A 5.6 kilogram mass is on an horizontal table attached to a string, frictionless pulley hanging on the end of the string. The coefficient of friction between M1 is, so here we have a mu They say coefficient of friction. I believe that would be kinetic. They don't say it. I have to assume it. Okay, that's okay. Because it's going to be moving, isn't it? Is it moving? So we're assuming it's moving. Hopefully I don't do all of this with MUK when I should do it with MUS. So this is the diagram. Let's look at the forces. Let's put all the forces. On M2, we have FG2. We also have a tension. This tension is the same pulling this block, tension, and this block has an FG1 and a normal force, N. I would call it N1, but we don't need it for the other one. Just N. Is there friction here? Yes, there is friction. So friction will be this way because the block will be going this way. Can we go back to note taking? So what is the magnitude and direction of the acceleration of M1? So M1 is here. We want to know what the acceleration 1 is going to be. Go back to note taking. Not the easiest problem. But let's work with M2 first, because M2 is the simplest one. It's also the one causing the tension and causing the acceleration, because that tension will be greater than the friction force. Also, let me move this here and add this. And so I can write Fk as a friction force. Okay, so clearly this is the problem right here. This is the problem. What's the acceleration on this mass 1? Okay, so basically this part right here will help us find T, which is used here in this problem. So let's take a moment and look at that. So let's sum up the forces in Y. Let's do F net for the second mass. So F net will be equal to T plus Fg2, and that will be equal to M2A2. So T plus, okay, so let me just first write T equal, because the goal will be to find T and bring it over here. T is going to be M2A2 minus Fg2. Can we calculate it? Not necessarily, because we don't have A2, right? Let's keep working on this for a minute, because this is going to be useful. We're going to need this. So first things first, M2. So A2, I want to talk about A1. So in terms of A1, A2 is equal to what in terms of A1? Is A2 equal to A1? Right, so A2 is the acceleration here. It's a Y value, right? So in this case, we just want to compare A2 and A1. Okay, so if A2, okay, so if A1 goes this way, it's a negative value. And what's going to happen to A2? A2 will also be going this way as a negative value, right? And if for any reason, I would maybe pull on the block so that A1 would go this way. Then A1 would be positive, and A2 would go where? It would go up, right? Because as I pull the block around like this block goes right, and this block goes up. And in both cases, right is positive and up is positive. So in this case, A2 will be equal to A1. There won't be any minus A1 or minus A2. It's literally, if this one is positive, then this one is positive. Can't see you. And if this one is negative, then this one is negative. This is important because of this. So I want to change A2 and A1 for, I want to change A2 for A1. And maybe we don't need to do it here. Maybe we could do it later in the formula. But to recognize that this is the case matters. I'm going to bring this over here. And it simply states that when one is positive, the other one is positive, and when one is negative, the other one is negative. Let's continue with this formula for now. E2 minus M2G. So this is our tension. And we're going to need that. Can't see half of what I'm doing, right? We're going to need that over here with the T here. So we're going to need that equation. So it's useful to have it. I think we're done with this part, right? We're kind of done with that part here. So let's move on to the other side, this whole thing. Okay, so with this thing, I always start with, so we're going to do two things. We're going to be doing the sum of Fy, right, equal, etc. But we're also going to be doing the sum of Fx, because there is forces in the y direction and there are forces in the x direction. So do I need to decouple them, or can you see them? Fy is those two. So we have Fg and N. Let's write that down. G and N. And those are equal to 0 because the block itself is not jumping up or down, right? There's no movement in the y direction. There's going to be movement in the x direction, but there will be no jumping up and down from that block. If there's no movement in the y direction, then this part is 0. In the Fx, what do we have? We have a force of friction and a tension. So we write tension plus friction. This time, though, it will not be equal 0 because I believe that block is going that way. We will not assume that it's 0. We will instead write MA. And this is A1 and M1. So let's write that down. M1, A1. Okay. we're going to work with this part. So again, we're trying to find this guy and isolate this guy. Can we change this t over here for all of this? Right? Can we change the t here for that? We should. So we'll write t equal, no, none of that. T plus fk equal m1 a1. Now I'm noticing fk, so fk, if you don't mind, I'm gonna edit this live. So this part I'm gonna bring with me for a minute, south, and we're just gonna talk about fk here. So fk here is equal to what? N, what is it? Minus mu kn, right? This is the force of friction. So in order to find the force of friction, we need this, which we have. We'll also need n as a value, and it's right here. So that's why we do this part when we have this part to do, right? So n here will help us find the fk, which will interact with the tension. You get it? So every time you have a complex system with 2 dimensions of forces, you always need this part because you need the n here. You don't see that. That's a problem. Okay. Okay. So n is equal to what? N is equal to minus g. N is equal to minus m g or m1g. And n is equal to, what's the mass? 5.6 times the gravity times minus 9.81. N is equal to, we'll use a calculator. So finding n is very easy. Very easy, because it's often just, n is just going opposite to gravity. 5.6 times 9.81. 5.54936 Newton, the vector. This time we're here. We need fk, which is mu kn. We could find it, one thing at a time. This is how I used to do physics. Fk will be minus 0.28 times n 54.936. N is a positive vector because it's pointing up. This is positive, everything's good. So fk will be. So in this case, fk is minus, because normally that's the equation. But is it true in this case? Is fk a minus value or a positive value? Right? If you look at this vector, fk is pointing positively. So fk is a positive value, and p, which is a tension, would be the negative value. So let's write that. So k should be positive. So there's no minus here. 0.28 times this. 1538. 1538. Newton. This is the friction force. Let's take back this equation. For which we have to find A1 tension over there. Let's change this tension, M2, A2 minus M2G. Is the tension plus Fk, which we found is equal to M1A, 1. So now we're going to deal with these two. Okay, and we've seen C from diagram that A2 is equal to A1 in direction positive, positive, negative, negative. So we can write, so basically this is what we're writing. So M2A1 minus M2G. So what this is doing is that it's literally saying that the value that we have here is A. The value that we have here is A. It's not minus A like the previous Atwood machine. So instead we'll just call it A. And we could remove the A and A1s, but I'm gonna keep A1 just because it's the same value. Plus Fk is equal to M1A1. And if we divide this side by M, which we will do, then we'll get the final almost. No, we won't do it now. Hold on. So now we have to isolate those two. Okay. M2A1 minus M1A1 equal, we're moving this on that side, we're moving this on this side, we're moving this on this side. Minus Fk plus M2. Is that it? That's it for that. Now we can isolate A1 into M2 minus M1. Fk plus M2G. At this point, you're probably like, what in the world is this? I thought I signed up for a physics class. Yes, this is a physics class. But what you're noticing here is the creation of tools. So what I'm doing is I'm doing math without any numbers. Mostly. Like I haven't put the Fk in. We've created a tool that is used for an Atwood machine with friction. So this is an Atwood Atwood on a table with friction. So if I draw it again, this table, okay, and then width difference between 5, 6 and 3, 4 is 2, 2. I often get those wrong. Oh, I'm just gonna check. Yes. Great. Well, we can see there's an issue. So 15 and 33, if you add them up, it's 45 divided by 2. 45 divided by 2, 44 divided by 2 is 22. It all makes positive, so it would be an acceleration that's positive 22, which doesn't work. Doesn't make sense. Add them up, we can see how we can get 2 here. If this number is much bigger, then it will reduce that. So we get this from this part, which is this part. And if this was a plus M1A, then this would be a minus M1A1. Let's review the whole thing. These are the forces in action. When A1 are the same, but not T. Right. Not T, not this time. So it is true that it's the same value for T, but in our diagram here, T is negative, and that's why they put a negative in their equation. If I call this T1 and T2, we can say that they are the same value. We used to write things like this. T1 is the same as T2. Okay, the value is the same, but their direction is not the same. So T1 is actually equal to minus T2, because if this tension is up, this tension is back. Again, this tension T1 is going up, the tension T2 is going back, right? Like the greater T1 is, the greater T2 is. It's the same tension, but it's clearly pointing, one of them is pointing plus, the other one is pointing negative. So I also have to state this. If we state this, we can put little ones here, little twos here, T2, and since T2 is equal to negative T1, then, or at least the value, then we must have a negative T1. This is negative T1. By having a negative here, right? That's T1, right? Okay. Having that's negative here, gonna change this and this, the minus, moving them around will change this. Sounds like a bad idea. This and but this actually makes sense now because this G is negative, and that gives us a positive mg back. Okay, and then we put a negative here. Okay, so positive m2g, this one became negative m2g, plus fk became negative k, and this positive m1a is the negative m1a. minus M2A1 is minus M2A1. Everything looks good. Now let's review. So the minus can come out here. And instead of having, inside the brackets here, minus M2 minus M1, I'm bringing the minus out, is what I mean by this. So this means that both of these values are positive, and we can change their position, M1 and M2. This minus is not going to stay there. We're going to move it. I'm going to move it with this here, this stuff here. So in order to remove the minus A1, I have to divide by minus. And I'm also going to divide by M2 plus M1 on both sides. Minus M2 plus M1. The minus go away. The A1 leaves, it stays alone here. All of this is gone. So A1 would be equal to. So the minus that's here is going to affect this minus and this minus. It creates a FK positive. By the way, let's write positive in the FK, because that's how we treated this FK. This FK was a positive FK because it's going right. Plus M2G. G is negative. I can't wait to try this. And then M2 plus M1 can be written M1 plus M2. They like the bracket. Looks nice. Let's try that. Let's try. So the reason why his formula has a negative FF because it's going the other way. Okay. Gonna work out. I'll make it work out. So this would be the formula. Let's try it out. So FK would be positive 15, right? What did we find for FK? We found positive 1538. And it is positive because it's going right. That makes more sense. I'm going to do the bottom part first. So 3.4 plus 5.6 will give us that's 899. So we want to get 2 here, right? That's the answer. So 15 divided by 9 is close to that. M2G. This is M2. This is G. This is minus 33. Okay, so 15 minus 33, that's going to work out. Yay. 15.38 minus 33.354. I don't know why my neck is hurting. I'm working like this. 17.9. A minus also interesting, means it's going downwards or backwards, right? Which is the case. This A1 is the one on the table and it's going backwards. Like if it would be a positive 17, that would make no sense, right? Over 9. Minus. Do we say 2? Well, it depends on your precision. 1.997 is my precision after 3 numbers. So I'm going to keep that meter per second square. But we get that they want us to find 2. Okay, so definitely this works. This is a good formula. Works. But in this case, fk was positive. That's our job. I've never seen a physics class where we don't have to figure out if fk is positive or negative. Okay, so that's always our job. And if you take g as a negative value, then this is your formula here. Very good, very good. So what now? They just want us to use the formula and not have to do all this work? Let's use the formula again. So this is the Atwood formula for a Atwood machine with a mass on a table, with friction or without friction, just won't be there. Accelerated along a frictionless table. So this number 2 here. I want to try something. Note, focus. We're not screwing around, we're cutting it all. I saw, dude. I lost it. No way. Something like that. You can see most of the page. Is it useless? I'll do that for now. So it says that the a 19 kilogram mass is accelerated on a table. Let's draw it. We draw our situation first. Educational. Okay, so this is the situation that we were going to deal with. So we're going to take all that information, bring it on the table, on the paper, I mean, and draw some kind of diagram. like this. Very reasonable. Draw the forces involved. E, F, G. This is the first mass? No. Well, hold up. I don't think it matters much because our formula is forgiving. There's a tension here. We have no friction. We have no friction. We don't need to draw it at all. There is Fg, which we will call Fg2. And there is normal force. Mass here is going to be mass 1. But mass 1 is not the first one in our problem, but the second one in our problem. This is the 19 kilogram mass that is accelerated along a frictionless table by an 8 kilogram mass hanging from the table. What is the acceleration of the mass along the table? So A2 equals what? And I think they wrote it that way, so you would write M1 and FG1 doesn't matter, shouldn't matter. So what do? We can redo the situation and the equation, or just use the equation, right? So without friction, we're looking at the net force over M1 plus M2. This is probably how most teachers start things out. I don't like it. F net. What's the net force on this poor thing? Notice how this is talking about F net in the X direction. So we only have a tension, right? No friction. And the tension is equal to Fg1. Go back here. M1 plus M2. Tension is equal to what? Tension is on this side, right here. It says that tension would be equal to minus Fg1, based again on the idea that F net is equal to, oh no, it's not equal to 0. Hold up. I'm trying to save time by not doing everything. I should either do everything or just take the formula. Plus M2G, so we don't have friction, this is gone. We just have M2G. So goodbye formula. M2G. So that's why they made that problem like that, because in this case, it's not going to be M2, but M1. Right? M1 is F1G. M1G is F1G, FG1. And so this is the tension. This is FG1. This is causing the net acceleration is the only force. So 8 times minus 9.81 over 8 plus 19 become easiest problem. Yeah. When you understand it, it becomes the easiest problem. 7848. Oops. Over 27. So the acceleration is minus, right? Which is true because it's going in at the left side is a negative, or it's either going down. It's both of these masses acceleration is found right here. 78 divided by 27 equal 2.9 07 meter per second square. No, why is this not good enough? This is good enough. In my face. 2.9 to the left is the minus here. Am I a better teacher than this? I don't think so. I think I'm a better physicist at this point than this is trying to make us understand. But sometimes being better at something is worse at something else. This is part where I'm questioning myself as a teacher. So we could say that F net. So F net is going to be only the tension. The tension will be equal to what? It will be equal to minus Fg. 1. And actually, the tension is negative. Right? That's where all the negatives are. They're all crammed here at the same time. If we talk about T1 and T2, it's a little simpler. Because in this case, F net on the second mass, so, and it's the y-axis, will be equal to T2, right? There's only that. If you look at the sum of the force in X, you only have T2. T2 is equal to negative T1 because it's the same scale, but it's this. If this one is negative, then this one is positive. Again, we don't choose the direction of the tension. Tension exists, if you want. In this case, it's caused by this mass, but it creates a positive tension up for T1, and it creates a negative tension left for T2. And there's nothing you can do about that. You can only, what's the word? You can only label them if you want. So let's go back here. So T2 is going to be equal to minus T1 because it's the opposite direction. And if you go back here, T1 is equal to minus Fg1 because it's, again, the same scale, opposite direction. So minus, so T1 is minus FG1. And the two positive here cancel out. And that's why this ends up being a positive M1G. 8. And we can basically go from this step to this step if we realize that T2 is created only by Mg. Right? If we realize that T2 is equal to Mg or M2G, you realize that with your eyes, then it becomes a little simpler. You don't have to deal with the minus. But if not, then this remains the truth. For the problem below, write an answer. A force of 40 Newton accelerates with no friction. What's the acceleration? This one is pretty simple, right? 40 divided by 5. Why is it so simple? Because there's no friction. And we have a force that's accelerating a block. Why is this even an example? With friction this time. Now that is a different ball game. So friction problem. Force of 40 Newton. Accelerates a block by 6 meters per second square. Mass is 5 kilos. Along a horizontal surface, how large is the frictional force? F. K. Fk because it is moving, right? Let's first draw the situation and see how complex it is. We have this mass, 40 Newton. That sounds positive to me. F1 accelerates a block M, so this is a mass M. I don't know, I'm writing. It has an Fg and a normal force by the table, pushing it back up. Is there friction? Yes, there's friction. So friction is backwards. Fk. Friction is always pulling back. So if we are pushing this way, friction is always pulling back. I'll remove the A. This is better. So here we want to ask the same questions we did prior. We want to know what Fk is. In order to know Fk, there's a formula for Fk, right? Minus mu k n. So the minus here, notice that the official definition is a minus mu kn. The minus implies that it's backwards, negative. It's going in a negative direction. And this is the case for our drawing. Mu is always positive, 0 point something, never negative. And n is always positive because n is pushing back up. The Earth is pushing up. We don't have n. Can we find n? Yeah, we could say n simply is negative fg because it's equal in value to fg. And we know what fg is, right? So we can say fg. This is how I used to do the physics. Fg is mg. Fg is 5 times minus 9.81. Fg is minus 49.055. This is good. And then we say that n is equal to minus 49.05, which is newtons. And then Fk finally is minus, so what's the coefficient? Wait. What's the coefficient? Huh. We don't have the coefficient. In fact, the coefficient, sorry, let me show you the issue. So we're given this, which I noted. Then the problem arises that they're asking me what the frictional force is, but we don't have mu k. We don't know what type of block it is and what type of surface it is. We can't look it up. We don't know what mu k is. So if you want me to find this and you don't give me this, can't find it. So it's not going to be using this idea. Plus, if I look at the next question, it literally asks what the coefficient of friction is. So it's basically asking you to find this first in A and find this in B. This means that this formula will be a B. The formula we'll probably use for B and not for A. Nice. Because now we can actually dive into the problem. So which other formula has an Fk in it, but is not this one? It's the one that we have to make. We have to make the whole thing. Let me just clear this up a bit. All of this is good, very useful. But this is the start of B. So let me pull it down. And we're going to write B. Because this is going to be the start of B. Okay, let's go back up here. So how would you start this? We have to make a set of equations using these things. You should always start the same way. Sum of force in X, or F net, is basically F net, but this is the X version of F net. And we're also going to find the sum of the force in Y, which is also the F net, but the Y part. So let's sum the force, because you can't add this force to this force. It's not gonna work out too well. We want to add. Let me go back here. We want to add this force and this force to know which way it's going to pull. And we want to add this force and this force because it's equal to 0. Remember? Sum of X is going to be, so what are the forces in X? Fk, which, by the way, we should note here that it's going to be a negative Fk because it's going left. What else do we have in the x-axis? We have the f1. Okay, and all of this is going to be equal to what? Is it going to be equal to 0? If it's equal to 0, there is no acceleration in x. And that's not the case because here, sorry. Because here we have an acceleration. Is that an AY or an AX? So the problem meant that we would push the block and it would accelerate in the X direction, right? So this right here is an AX. It's a good thing because if we sum up the forces in X, we end up with an MAX. And when we'll sum up the forces in Y, we'll end up with an MAY. And this one is 0 because there's no acceleration in the y-axis. There's not an AY that's accelerating upwards. So AY would be 0. So that part will be 0. Okay. So let's do the y part. We have n, we have fg, and those two will be equal to 0 because they equal out. Okay, so now let's work with this part, and let's work with this part. And by the way, we do see here the fk that we're going to find using those two equations. Well, since we want to find fk, we might as well leave it out like this and write max minus f1. Do we have both of these things? Do we have all these three things? If we do, we can find fk. So fk is, mass is 5, ax is 6, f1 is 40. 5 times 6 minus 40. Fk will be equal to 30 minus 40. Fk is minus 10. Can you please explain your answer? Explain your answer. So minus 10 here. If I have a minus 10 and I have a 40 here, together they make a 30, a positive 30. And if I divide that by 5 kilograms, I get an acceleration of 6 meters per second. If I did not have a 10 friction, then we would have a 40 positive divided by a mass of 5, which would give us an 8 meters per second acceleration, right? Which is not the case. There is friction, and so we have a lower force. We found the friction force. Now we'd like to find the coefficient of friction. So if this is A. So you'll notice we haven't used that part yet. We'll get to that. So let's do B. But this time there might be an easier way to do B. So B would just say Fk is minus mu Kn, and we have to find mu K. So basically mu K is equal to Fk or minus Fk over N. And all I did here was divide both sides by minus N. Divide by minus N. You end up with this. Right, minus go out, the N go out, mu K is equal to minus Fk over N. We have Fk. minus, so minus, hold on, minus 10. You have to see it. You have to pay attention. N, we need this. Right, so found N here. So you can see how we had to go through this process. But before we go there, we assume something here, which I want to talk about. I'm sorry, I'm taking all your time. What did we assume when we said that? We assumed this. Right? Where does this come from? This comes from fnet equal this, which is basically this part right here. So you can see how doing both of these parts will play out over here. So let's do the work we haven't done that we should have done before, just because we know we're going to use it. So n will be equal to minus fg. Okay, and then once you have this, all I mean to say here is that when you have a two-dimensional diagram of forces, take a second to do both of these sums. You're summing the force in x, you're summing the force in y. They're both useful because they both give you useful information. Okay? We're going to keep this in our mind. And when it's time to do B, which we started here, we are allowed to put this in. Find the answer, finish. Let me just put some order here. This. Question B. This is what we assumed. We did not assume it any longer. This is B. This is the final work of B here. See now. B kind of goes on this side. Plus N, so this becomes this, and then the N 49.05 K UK. Minus minus cancels out. It's good because mu K is always a positive value. Always, always. 10 by 49 is about 0.2 or 0.195. 0.2. 10 Newton, yeah. Here. I want you to do the next one. You want to pause me again? Oh, you got the answer already. Too fast. 2. You got a 200 kilogram. You should pause me and do it. 200 kilos. Great. Pushed horizontally with a force of 700 Newton. If the coefficient of friction is 0.2, calculate the acceleration. So when they say acceleration, it means it's moving, so it's a K here. I'm just taking the information. Studio, get to it. 200 kilogram crate pushed horizontally. A force of 700 Newton will take the positive 700 Newton, push it that way, horizontally. If the coefficient of friction is 0.2, what is the acceleration? This is a very complete dynamics problem for our grade. So we first draw the situation. And we put the vectorial information. F1. Is there friction? Yep, there's a coefficient of friction. Fa, which will be negative. There's a normal force. There's Fg. That's it. Okay, stop me right now and go do your problem, because I'm going to do it now. Always start by summing up the forces in X and Y. In X, we got Fk and F1. Is that equal to 0? No. So we'll keep MA and we'll label AX. We're also going to move this. We're also going to make sum of Fy, the forces in Y. There's N and F, and they're both, are these equal to 0, right? They're equal to MAY, but is there an acceleration in Y? No. There is no Y acceleration. There's only a X acceleration. Studio. Thank you. So maybe you don't need to dedicate half a page for this, because this, if this is equal to 0, all we care about here is this little sentence. Okay. How will this ever be different? Well, you never know. There could be someone sitting on this mass making another force in Y, right? And then you would have to add that force here, and you would then add it here, right? So you can see how it's still useful to sum it up to get the real situation. We're just having good habits. So we got this information. We're happy with that. The X part is where most of the equation is. We're going to work with this part. The goal is to find A here. Is that AY or AX? That's AX. So we're looking for this. So we could rewrite our formula. AX is equal to Fk, which is negative Fk, by the way, plus F1 over M, right? Simply divide both sides by M. At this point, you could either do algebra or arithmetic. So if you do algebra, you would change this to mu kn plus F1 M. And then the n here, you would change n for this, minus Fg. We're doing algebra right now, right? It's better to do algebra because it's less numbers. And then basically you have almost everything. Like Fg, it will be Mg minus mu k. So minus minus cancel out, and then Fg becomes Mg. So mu k Mg plus F1 over M. Don't cancel out these m's because f1 doesn't have an m to cancel out. Oh, goodness, my head. Might be the last problem. Instead of doing algebra, what you could have done here on this side is calculate what you can calculate. So if fg is mg, you can write this. You have m, you have g. M is 200 and minus 9.8. Sorry. N is 19.19 Newton. And basically this after this n, you could either put it in here, or you can even find fk at this point. Say, oh, I have n, I can find fk. Yeah. Instead of doing algebra, you see, I took the one formula, found something. What's mu k again? 0.2 times 19. So divide that by 5. That's 16. 20 times 9. Calculator, please. Oh. Wait a minute. A fifth of 2000 is 400 minus fifth of 20, which is 4. 2000 minus 4 is 1996. 400, 396. So FK is minus 396 Newton. Right, so basically we did that part right here. And then FK, you did that part right here. That part, that's already done, right? So if you didn't want to do the algebra part, which is fine, which is really fine, you want to do this like that, and after that, you just need to take this formula, the last formula. Okay. Right, like basically, which path do you want to take? You know, you've got those two tools here. You can either develop from this side first. You got N, you know you're going to need FK. You can even bring this on this side here and say, okay, I needed FK. Forget FK. I need that. Because you have F1, I think. You have M, you have everything you need. You need FK. So after you found N, you can find FK. Are you getting my point? Yes, then you're on top of it. You are. The last formula, AX is FK plus F1 over M. AX, FK plus F1 over M. We said FK was negative. Let's double check, right? The drawing, FK is negative. Or good, because FK is negative. And it is negative because we put a minus in the equation. Minus 396 plus 1. 700 divided by 200 kilograms. Your acceleration, so 404 divided by 2 is 2.01. About. And it's positive, right? The answer is positive because the math is positive. Is that true? Yes. The force is greater, 700, and it's pulling it into the direction, the positive direction. No! God, no! No! Okay, so where did I make a mistake? It'd be here, right? If I want 1.5 here, is this the mistake? When I did 0.2 of 1980? I don't think so. 0.2 times 1980. 6. This is true. Is this 200 times 9.8? Because it's all in my head, right? So you can make mistakes. 1960. Okay. That's not enough to cause such a big change. 1960. 1960, that gives me a 2 here. Why am I doing this? It's all wrong. Hold up. 2. Basically, this is like this. Not helping. So we're gonna review the whole program now, the whole thing, and decide if I made a mistake or if they made a mistake. Actually, we can take the 1.5 and try to come up to where we are, right? So if the answer is truly 1.5 here in the acceleration, then 1.5 times 200, which is 300, should be equal to Fk plus F1. So F1 is 700 plus 700, and Fk should be negative 400. Is that what we have? Yes. Oh, I can't do math. Oh. So that's what we have. We have the same thing. So what I did here is I did about 400 divided by 2. And it should have been 300 divided by 2, right? 308. Right? This is not 408 divided by 2, but 308 divided by 2. That's my mistake. Oh, are we done, man? Yes, we're done. Please, if you have questions, talk to me. Thank you.